Yes, teacher.
Any person with a question at this point?
Yes.
Okay, part 2. What was
Kinetic energy. Find the kinetic energy.
where? Before it is released?
Yes.
Oh, no, for that case, what do you do? What is the formula for kinetic energy?
A half mv squared.
Man, I did all, and I'm proud of me.
So when we substituting, what we put where there is v squared, what we put there where there is v?
Shall we put 0?
Why do we put 0?
Because there was no velocity. It was still at potential. It had not yet been released.
Yes, it was not yet released. It had not been yet released. Therefore, because they said it was at rest, if it is at rest, it means its velocity is 0. Its speed is 0 when it is at rest. Therefore, where you have v, 0, and the entire answer becomes 0. So that's how you are supposed to be getting kinetic energy before it is released.
Teacher?
Yes. Ask your question, someone was asking.
0 was because there was no speed in this equation.
Hey. 0. What? This is 0, right? This is 0 because before it was released, it was at rest. When I say at rest means, whenever I say at rest, it means speed. That's what it means in science. The word at rest means the speed is equal to 0. And before the kinetic energy, before the body was released, before it was released here on this top part here, it was at rest, it was not moving. So they ask you for the kinetic energy at that point. Then why this mass is still mass doesn't change. Mass is 20. Where you find this V, you put there 0 because at that point it was not moving. Now when you multiply anything with 0, the answer will always be 0. Any question? Hila, you mute your audio. I think it's coming. So many sounds. Rosette, is it Rosette? Katusime. Can you mute? If you're asking a question, that's when you can unmute. I'm seeing Titani, Shanice. If you're not asking, please you mute. Those sounds come from your side. The back. Now, Tanda, do you have a question? Now, Tanda, is there any question so far? Elena, if you have no question, then you mute. I'm seeing your audio, not muted. Okay, good. She has muted. Rosette, Katusime, do you have any question? If you have no question, please mute your audio. Click on that microphone and you mute. Then Nasasa. Can you mute your audio? Because you have no question, but your audio is still open. Please, you mute. I think some people are unmuting. Who is using Technopop 2? Can you put your real name? Can you Technopop 2, put your real name? I'm going to remove you from the list. Techno, who is Techno? Please, can you say something? Techno. Use your real names. Otherwise, I'm removing you. And when I remove you, you won't attend to the next lesson. How do you change your name? Just go to your name. You Put your cursor on that name. Your name is the starting name. It's the one that starts the list. Put a cursor on your name, then it will show you something like rename. When they
3 dots, they'll show you 3 dots, then you press it.
When you press, what do they do? There is some part where they say rename. Then you click rename and then you write your name. You have seen it? Okay, let us continue. What was part 3? I hope the person who was asking why we have put 0 is now answered. I answered that person who was saying why is it 0?
Yes, teacher.
Okay. Stacy, you are reading for us the question. So can we go to part 3? What was part 3?
Potential energy when it's halfway the building.
Potential energy.
Potential energy halfway. And halfway. So the formula for potential energy is mgh. First of all, when it's halfway, the half will be this. Halfway. Halfway means get your 40 divided by 2. So potential energy then becomes mgh. What answer did you get?
Listen.
4,000 joules.
Listen.
4,000 joules. That is the potential energy halfway. Are we together?
Listen.
Yeah.
Okay, let me
Don't chat. Don't.
now be Mariam, can you mute? Your little sister is making noise. Can you mute? Put some now. Beja Katusima has failed to mute. Shakira is not muting. Remina, can you Remina mute? You mute very fast. I want to explain something before I continue to part 4. Yes, Katusima also mute. I think that Regina has unmuted. Okay, now let me explain something very true. Be careful what I'm going to explain. At point, if for example, I put here point A, maybe halfway it is point B. Maybe the last point here is point C. Now we are going to notice that at each point, we have the total energy does not change. If I do like this, at A, at point A, point A, mechanical energy. What is mechanical energy? Mechanical energy, we say it's the sum of these two. Mechanical, whenever they talk about mechanical, Stacy, mute your audio. When they talk about mechanical energy means the combination of the two, potential plus kinetic. Now, when I check this point at A, at point A, the potential, this is before, this is when it was not yet released. And we have just seen its potential energy is 8,000. So when I put here 8,000 and the kinetic was 0, I'll end up with 8,000 joules. Now, what I want you to be careful with, that the total, this mechanical energy at any stage will always be 8,000. Any stage, mechanical energy will always be 8,000. Whether you are halfway, whether you are at the bottom, or you are at the top, this mechanical energy, total is always 8,000. Am I making myself clear?
It's Bambi. You can't hear when you're over.
I'm seeing somebody. Rahmachi Gun, can you mute? Huda, Siraj, mute. Mute, you click on the microphone to mute yourselves. Zalfa, and Chigundu. Huda, is it Huda? Huda Siraje, mute yourself.
It's 7.
If this one doesn't mute, I will remove her. This Huda. Huda Siraje, are you in class? I think you are still discussing with your people and then you are also attending class. You do one thing at a time. Listen to what we are telling you from this side. Huda, mute. Okay, I have to repeat this because if you understand what I'm saying.
I'm not in any game with you. Okay, take care. Yeah, we go to my class.
Huda Siraje. This Huda Siraje. Very confused. People, have you gotten what I'm saying? At point A, this point, mechanical energy is equal to, this is mechanical. It is always the sum of the two energies, potential energy plus kinetic energy. Potential was 8,000. Kinetic was 0. When I add, I get 8,000 joules. Now, I want us to come to this point B. Point B, if point halfway, we are going to check. At halfway, we have seen potential energy is 4,000. Halfway. Now, if it is 4,000, if they ask you for the kinetic energy at that point, what do you think will be the kinetic energy? This is why I want you to understand this statement. That at any point, the total energy should always be this. Total at any point. So when I do like this, at point B, mechanical energy should also equal to potential energy and kinetic energy. What is the potential at B? B is the halfway. This is halfway. Halfway. What is the potential at B? Halfway. The potential at B has been 4,000. But what is the mechanical energy at B? What is the mechanical energy at point B? What should be the mechanical energy at point B? Mechanical. Who can tell me that answer? What is the mechanical energy at
4,000.
Mechanical?
8,000.
8,000. I have not yet asked for kinetic. Eh? This mechanical here, this one mechanical, all the points always be 8,000. The total that was up here is always the total everywhere. So mechanical energy does not change. Its total is ever 8,000. So if the total is 8,000, but the potential has been 4,000, so what will be kinetic?
It will be 4,000, teacher.
Yes, so shall get our 8,000 minus 4,000 to help us get. So kinetic energy is 4,000. In other words, what people were making, were confused.
Class is this?
What people were confusing, they wanted to have the formula because they are asking me when
You
they
put me in south. Yes. What are them south?
where any promise.
South. No, yeah, you get them south.
Yeah, your class teacher Namgambia East.
Can you
We
please
don't
mute
have
yourself?
a clock in our class. This is south.
You think
And
your
their
Bible-
ways of studying is different.
So, the person using user, can you mute yourself?
Music is us.
Somebody who is putting the word user, mute yourself. You are interacting in the class. Mute at the same time, rename yourself. We don't know your name. Rename yourself. Then Swabra, mute. I see Amina, you're putting up your hand. What's your question? Amina?
Teacher,
Yes.
teacher, for me, kinetic energy when it's halfway the building, I also got 4,000, but I found velocity. Then after I used it in the formula of kinetic energy, I still got the same answer.
Hey, that is very okay. Somebody can first use, if you want, you can use this formula. That formula can give you the answer, only that it will take you a longer route. You use so many steps to come to the same answer. Now, the simplest way, the simplest way always to check the mechanical and the potential, because at any point along this path, mechanical does not change. It's always 8,000. The one you get in the beginning, so you always just say, if I have 8,000 here, and because potential is always easy to get, potential is just mgh, but kinetic is not very easy, since you first have to get velocity, then after velocity you come and substitute in the formula. The answer is okay. You also get the marks, but the challenge, if you make a mistake in finding velocity, that means the entire kinetic energy will be wrong. Yet this one is somehow simpler, that if you get potential first and you know your beginning mechanical, the total mechanical, then you just say at any point mechanical energy is conserved. Mechanical energy is equal to potential plus kinetic, then you substitute in, and you get the same answer, 4,000. So this one can give us the answer faster.
Okay, teacher.
Is it okay?
Yes, teacher.
Okay, the next part. What was the next part? Stacy was reading for us those questions. What was the next part?
Kinetic energy. Kinetic energy when it's halfway the building.
Hey, it is the one we have just got. This one halfway. It is 4,000.
The next one is potential energy when it's a height of 25 meters from the top.
Aha, now that one, some people made mistakes also at that point. Let us see. They are saying, they are telling us potential energy when it is 25. Potential energy at 25 meters at top. Now, in this number, 25 meters from the top, what was your answer? First of all, the formula for potential energy is very simple. It is mgh. Our mass is 20. G is 10. Now, what is the height? What is the height?
25 meters.
25 meters.
The height is 25 meters.
Hey. Okay. Hey. Any other person with a suggestion about the height?
25.
All of you have 25, eh? Actually, some person I marked and I realized it was not right. Let me show for you this diagram now. Let me withdraw it. 25.
15.
Oh, yeah. Who has said 15? I want to buy for you break. Who has said 15?
Now look at Regine. It was me.
Regina,
yes.
I'll buy for you break. It's very nice.
When I come back.
Here, the answer is not 25. The height is 15. We are going to see why.
Why?
Yes, I knew. That was the next question. Okay. If this is 25, what is the balance? Make it 40. What is the balance?
15.
15.
15. Now, the formula for potential energy. Potential energy is mass GH. Now, the H we are putting, that H we put in that formula is the H from the ground. Is the H from your reference level. It is from the level going up, not from up coming down. The H you put In all the formulas for potential energy, that height is always from the base going up, not from the height above. Even this 40, in the first question, we put 40 because it is the 40 from the ground to the top, not from the top going up. First, we don't know what is up. What we know from the ground to the stone, the top, is 40. So here, height, we have to note at this point that the height we always put is always the height from the base, not from the top. So for us, we can give you height from the top. Don't use that height from the top. Always use the height from the bottom. So that's why it's 20 times 10. What is the answer here?
3,000 joule.
3,000. So that's how that answer was supposed to be got. Can you make the corrections?
Teacher, my hand is
Teacher,
up.
what might
Okay, Aliyah, your hand was up.
Mine.
Okay, Condolence.
Teacher, for me on that number, I also got 3,000, but then I just, okay, fine, just chill.
You first got the other potential and subtracted it. Okay, but have you seen this method? This one is also a better method. I think can be simpler. Okay, I see Lukwago, your hand is up.
Teacher, I'm asking, why don't we use 25 meters?
What I have just explained, I have said, for potential energy, the height that you always use, if this particle is here, when it is falling down, if it is here, the value of its potential energy is from the ground up, the height above the ground, not the height above it. It is the height below. We always use the height from where you are to the ground. That's what we are saying. For potential energy, that height we use is from the reference level going up, not from up going the other side. That's why we don't use it. So whenever they give you 15 and they say it is from the top, then you just get the entire 40 minus 25 to get the one from the bottom. Is it clear?
Yes.
Then Elizabeth, Condolence, you are still putting up your hand. I see your hand is still up. Aliyah, did you just forget? Did you forget putting down your hand?
Excuse me, teacher. Teacher, I was asking a question. Like the question of kinetic and potential energy, isn't it like related to kinematics?
Is it like
about it related to kinematics? The question that
you have,
like about,
you switch off the radio. I hear some radio in the background. Okay. Columba, are you asking or you have forgotten to mute? Aliyah,
I was asking like whether that question about the potential and kinetic energy that you gave, isn't it related to kinematics, like about falling from the ground?
What is kinematics? What do you understand by the term kinematic? Kinematics just means motion. Kinematics is just motion. For your better understanding, it is just motion. Anything that has motion is under kinematics, kinetic movement. So it can be under that topic. I don't know why is it confusing you? Is it confusing? Why does it confuse you when it is not in that topic? It is under, it's all mechanics. Actually, we are putting them under mechanics. It's mechanics.
Yes.
And mechanics that has motion in it.
Yes.
But I was asking, have you understood why we are using 15, not 25?
Yes, I've understood.
Okay. Now, if they ask you for the potential, this is potential energy. What about kinetic energy at that point? What would be the, by the way, now to get kinetic energy, you see that we don't need to get the velocity. If they ask for kinetic energy, what would be the simplest way of doing this? Kinetic energy. Kinetic energy at 25 meters above the top. Somebody can first get the velocity. The way the other, or is it Stacy? Somebody said first got velocity, the other first number. You can first get velocity, but if you don't get velocity, we have just seen a very simple method of always getting kinetic energy. We have said, even if I don't have velocity, I can just say the mechanical energy is always equal to the potential energy plus kinetic energy. This is what you have said. Every time this conservation is true, conservation of energy is true. Mechanical energy is the total. And I have told you the total we got in the beginning is always the same total at any point that you reach as the body is falling down. So at this point of 25, what is the mechanical energy? What am I going to write here for mechanical energy? What we write? What can you write?
8,000.
8,000.
Right here, 8,000. Because for this one is always constant. It does not change. Now we have just seen the potential energy at that point when it's 25 from above is what you have just calculated. So here I put 3,000. Now the balance will be the kinetic energy. That's why at each number, whenever I could ask for potential, then my next number was for kinetic. Because I just wanted you just to subtract. That whenever is potential, the balance is kinetic. So here we get 8,000 minus 3,000 to get us kinetic energy. So kinetic energy is 5,000. So that's how, I think you are getting how simple you can always calculate for kinetic energy. Minus using the velocity formula. If I don't want to use the velocity, I can do like this. Are we together?
Yes, teacher. Yes, teacher.
What was the next number?
Teacher,
yes.
I have a question.
Okay, ask Stacy.
On that number of kinetic energy, I still got 5,000 joules, but I multiplied 20 times 10 times 25.
Okay, there.
Potential energy.
That formula is for potential energy. Okay, the answer is okay because when you get, now let me first explain why your answer was okay. Because for you got the energy that was lost. If your potential is 3,000, if your potential is 3,000, it means if you had 8,000, then you have lost 5,000. So that 5,000 is from this point in this region here. The one that has 25. It's what you have lost.
Yes, teacher.
Hey, okay, that's what
yes, I used kinetic energy gained is equal to potential energy lost.
That is okay. That statement is okay. That is okay.
The next question. The next question, find the kinetic energy as it lands on the ground.
Kinetic energy as it lands on the ground. What was the answer there?
Teacher, it was a bit confusing. As it lands or when it has already landed?
8,000 joules.
Okay, in that case, we normally assume that just before it lands. But in that case, you take it as if the ground.
You guys mute.
Whenever they say just before it lands, we always take it as if it is like on the ground now. That's what we always say. Yeah, we shall say potential energy loss. Energy.
You guys can
Namugamba, can you mute? Yes, Namugamba is muted. Chirabo, mute. Chirabo has muted. Sapphire. Sapphire, can you click on the microphone to mute Sapphire? Yes, Sapphire is muted. Kimuli, mute. Oh, very nice. Everybody has muted. Please don't unmute before, unless you want to ask a question. Don't unmute, don't tap on that microphone. It will unmute itself. But when you want to ask a question, put up your hand like Stacy and then ask. So before it lands, just before it lands, we shall say kinetic energy gained is equal to potential energy lost. And what potential energy have we lost? What was the potential energy that it had? It had 8,000. So we have lost 8,000 joules. Or somebody can say mechanical energy is equal to potential energy plus kinetic energy. This is 8,000. Potential energy is 0 plus kinetic energy. Why are we saying 0 potential? Because it has no height. At this point, it is at the ground, no height, so H is 0. Therefore, if H is 0, 0 times any of these numbers will give us 0. That's why we are saying where there is potential energy, you put 0. At that point, kinetic energy is 8,000. So you can use different ways. So long as you know this is what has been lost and this is what has been gained. Any question at that point?
No, teacher.
There was some other last part there, I think.
Yes. Potential energy as it lands on the ground.
Okay, we have indirectly answered it. It is 0. Potential energy as it lands. As it lands, it has no height, therefore potential is 0.
The last one was velocity as it lands.
The velocity.
So then the last part. Yes.
So
velocity as it lands.
Now for velocity, whenever they ask for velocity, we remember which formula has velocity. It is the kinetic energy formula that has velocity. Therefore, we shall just use that formula for kinetic energy. By the way, like in the other questions, I didn't ask for velocity at any point, but they can ask for velocity at any point. Here, anywhere, they can ask for velocity. Whenever they ask for velocity, immediately just use the formula for kinetic energy, so long as you know kinetic energy. So we shall have kinetic energy is equal to a half v squared. We have seen kinetic energy is 8,000. From what you have seen here, a half, the mass was 20, and this is v squared. When I simplify this, So I have 8,000 is equal to 10 V squared. 8,000 is equal to 10 V squared. So you divide by 10, if you divide by 10, this squared is 800. If it's 800, how do you get V? Just V.
Get the square root.
The square root. What is the square root of 800?
Teacher, 28.284.
I have rounded off to 28.3 meters per second. Meters per second is the SI unit of speed. Yes?
Potential energy as it lands on the ground.
A potential energy as it lands. We have said, whenever they say as it lands, it is always the one at the ground. But at the ground, our height is 0. At the ground, height is 0. If height is 0, then if you put in a formula for potential energy, the formula which says mgh, when I put here 0, the entire work will be 0. So whenever they say potential energy as it lands, put there h is equal to 0 and the answer will be 0. So the potential energy is 0 at that point. Are we together?
Teacher,
I have a question.
My hand is up.
Let me ask one by one. Let me ask with Amina. Start with Amina. Amina, what's your question?
Teacher, for me, I also got the same answer, but then I found the velocity is equal to 2gh. Then I continued like that.
Okay, it's okay. That is okay. Stacy.
Teacher, is it like a must round off? Because me, I just left it as 28.28 meters per second.
Okay, that is more accurate. That one you left here is more accurate than this one. If you can, sometimes you can have so many digits and you have to round off at some stage. You might not write everything, but the more digits you write, the more digits you write, the more accurate your answer is. Actually, we prefer for you to write all the digits. That is the best in science, but sometimes the figures can be many.
Okay, thank you, teacher.
Then I see Remina.
Excuse me, teacher.
Yes.
Excuse me, teacher.
Excuse.
How is kinetic energy gained equal to the potential energy lost? I didn't understand.
Hey, we said there is the law of conservation of energy. Law of conservation of energy means the energy you start with, the total energy you start with, is the same energy you will be having at all the points. So energy is conserved. Now when we say kinetic energy gained is equal to potential energy lost, what we mean, let me just go back to this diagram. When you have something like this, for example, here we had potential energy and kinetic energy. But before it starts to land, the kinetic energy should be 0, but potential energy is maximum. Okay, let me just use this figure, the one that you have been using. Now, let us assume we are here, halfway. When you are halfway, potential, then we also say at the ground. I'm putting both. Now, when you are halfway, we said halfway, our answer was 4,000. 4,000. If our answer is 4,000, should we here, the kinetic was 0. Should we also assume the kinetic is 0 here? Is it still 0?
8,000. Just potential energy lost.
Is it when the kinetic energy is 0? Now, when you reach this point halfway, half, potential is 4,000. Should we still say also 0? The way it was up here.
Yes, teacher.
Amina, are you getting my question?
No.
If your potential was 8,000 and the kinetic was 0 in the beginning, now when it starts to drop, it has dropped halfway. At halfway, we calculated potential was 4,000. So what should I put here for kinetic? Should I again put 0 here? Amina, should we put 0 here or what should we put here at this point?
4,000.
2. Go ahead.
4,000.
If I were to ask you, where has that 4,000 come from? Where has it come from? The 4,000, this one.
Teacher, we had said that the mechanical energy is 8,000. So when we subtract, you get 4,000.
But now that mechanical energy, the one that was 8,000, but in the beginning it was the total potential. So out of the potential that was 8,000, now we see our potential is 4,000 potential. It means we have lost some 4,000 of potential. Potential was 8,000. Now at this point, it is 4,000. So where has our balance gone? That balance that we have lost is what we give to kinetic. So whatever potential loses, then kinetic gains it. I remember somewhere we had 5,000. Our potential was 3,000. And then we said kinetic, after calculation, kinetic was 1,000. Using our mechanical energy statement, but you could see that potential was 8,000. Somebody has Chigondo mute.
People learn how to use your.
Chigondo mute. Chigondo and the Sebakala mute.
Sebagala, please mute.
Sebagala, okay, they have muted. Amina, am I trying to answer your question? How we say when this one is lost, this one gains it? Here, potential was 3, kinetic was 5. So whatever has been lost by potential has been gained by kinetic, because potential was 8,000, potential was 8. And then afterwards, it went to 3,000. Therefore, some 5,000 was lost. That's why we are saying that at any stage, the kinetic energy gained is always equal to potential energy lost. And how much have we lost here? We had lost the entire, because when you reach the ground, potential energy is now 0 when you reach the ground. But initially, it was 8,000. Now, it is 0. Where has this 8,000 gone? That 8,000 has gone to kinetic, because energy must be conserved. At any point, when you add potential plus kinetic, your answer should be the same. When I add 8,000 plus 0, I get 8,000 here. When I add this, I should also get 8,000. When I add this, I should also get like that. At any point, your potential plus kinetic should be the same answer.
Okay, teacher.
Okay, now there's some other number we are going to look at that has similar things. Is there any person that has a number which has calculations for kinetic and potential? Any person there, you give us your question. Our next topic, by the way, will be pressure. Pressure, the next topic, our next lesson, pressure. But let me give you this question now. Copy the question there first.
People, please mute.
Teacher, we can't see the board.
You can't see the board.
Oh, we have seen.
We can.
Your phone.
Can you guys see the board?
No.
Yes.
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 Teacher, what
Yes, we can see it.
Mommy, I can't.
Seeing the board.
Teacher, we done with the questions.
Oh, we have seen it now.
What?
Teacher, we done with the questions.
I'm putting first B.
Stop talking, Banai.
No, we can't see the screen.
You guys mute and then you'll be able to see the screen.
That is the question. Chigondo, you have failed to mute. Sometimes you mute, other times you unmute. You don't tap on that microphone. When you tap on it, it will unmute. You leave it. Unless you want to ask a question, that's when you tap on that microphone.
Teacher, please may you kindly dictate the questions? We can't see.
Guys, mute.
But I don't know something. Maybe your screen. A ball of mass 200 grams. A ball of mass 200 grams. Are you there? Falls from a height of 2 meters above the ground. Oh, this one, promise, mute. Promise and Miriam, mute. Can you now see the board?
Yes.
Okay.
Yes, teacher.
So I want you to work out that number and tell me the answers. Who has got part A? Me. Maybe I see. I see Vicky, Lukwago, Shadia, Shahida, Agatha. Let me give like 1 minute to the rest. At least part A first. Part A, Roman 1. Roman 1.
4,000 joules.
4,000.
Girl, I'm in a wait to talk.
Okay, you don't talk. Sorry. Okay, you don't talk, but you give your answers. I'm going to check. Let us give people a chance. At least Roman 1. I want Roman 1, Roman 2, Roman 3. Then we go through those ones. Then after we go to part B. Roman 1, what's your answer?
4 joules.
4 joules.
How did you get the 4 joules?
4 joules.
Teacher.
You change grams.
You convert 1,000 grams. I mean,
No.
200 grams to kilograms.
Okay. Mass is 200 grams. So you first divide it by?
Yes, teacher.
1,000 grams.
By the way, why do we convert it to kilograms? Why don't we leave it as grams?
Kilograms is the SI unit for
Mass.
mass.
It's the SI unit for mass.
Because kilogram is the SI unit of mass. And we said in formulas, we only put figures which are in SI units. So this is 0. We have to change the 2 meters to centimeters.
No.
No.
Yes, because already it's in the SI. And when you multiply this, you end up with 4 joules. That is part 1. Then part 2, kinetic energy.
4 joules.
Because we said, as just before it lands, the kinetic energy
gained is equal to
energy lost. And the potential energy that we lost was the one that we started with. What you start with is what you lose. So at the ground, the potential energy that you have lost is what you started with. It's the 4 joules. So you don't have even to put a formula here. Just use that understanding that whatever potential I had is now lost. It is given to kinetic. Now it is called kinetic. It's no longer called potential. That is how simple this number was, part 2. Then I want part 3. Are we understanding how we have gotten part 2? If you don't understand,
yes.
Okay, now.
No.
We have, whenever they ask you for potential energy, just before it lands, whenever they ask for potential energy, just before it lands, what we do, we first check what was the, whenever they ask for kinetic energy, then you ask yourself, what was the initial potential energy? What was the total potential energy before it landed? The potential energy before it landed was 4 joules. Now, when you reach the point just before it lands, because we say, when I said just before it lands, it means it's on the ground. If it is on the ground, it has no potential energy, 0 potential energy. All the potential energy has been lost. If all the potential energy is lost, where has it gone? Because in this topic of conservation of energy, we said we don't lose our energy, neither do we create it, but it just changes from one form to another form. So if you have lost all your potential energy, it means it has changed from potential to another form, and that other form is the kinetic. So we no longer call it potential, now we are calling it kinetic. But how much was it? It was 4 joules. Therefore, even the kinetic at the ground is also 4 joules. Started there? Okay, how did you get the velocity? Velocity.
a half mv squared.
Yes.
Kinetic energy is equal to a half mv squared. Then we multiply a half times the mass, which is 0.2 times velocity squared.
Okay, so we get 4 to a half. The mass is 0.2 times this squared. Then when you cross,
then I didn't do that.
You can use now different mathematics concepts. You can first simplify by half, you get 0.1. Or you can multiply this side. I don't know which one you use. Yeah, it's just mathematics. Just use any mathematics. This one, let's see people are complaining. Okay, when you divide 8 divided by 0.2, what do you get? Get
40.
40. The square root of
Excuse me, teacher. Excuse me.
Yes. What's up?
I'm confused. Where did the 8 come from?
I cross multiplied. You know what I did? I didn't divide this and this. I just multiplied 2 times this side and 2 times this side. So 2 times 4 comes to 8.
It's the same thing if we multiply.
It's the same thing when you divide and multiply. It's just mathematics. Depends on what is easier for you to use. You can divide this. Remember, you can do by 2, 1, by 2, 0.1. Remember that. So you come to the same answer. What is the square root of 40? And then you check your answers with the one I'm going to get.
6.324 meters.
Okay, that's right. So whichever method you use, whichever mathematics you use, you come to the same answer. We are together?
Yes, sir.
Teacher. But now, that last part, I want this last part.
Yes, teacher.
Part B. What do you do with part B?
Teacher, I first found the velocity.
The velocity after?
I first found the velocity, then I found kinetic energy.
Okay, this part was here. Then it was here. Then it was. After landing, it bounced. Now, this is point, let me say this is point A, and this is point C. How do you get that? What was the energy at A? What was the energy at A? Energy at A was the 2 joules, the total potential before it landed. Are we following what I'm saying? The energy
yes.
at A before it
Yes, teacher.
But now, how do you get the energy at B? They have given us the height at B. You can just use the same formula. Potential energy, because they have given us height. Potential energy is mgh. We are first getting the potential energy at this point. What do you get?
So why do you get the potential energy when it has bound?
For the loss in energy. Now for the loss in energy, because at this point, when something bounces and goes up, it reaches some point and rests, then it comes back. So since they have given me height, if they have given me height, now I can use the formula for potential energy to know how much potential it has at that point. And now I compare that potential with the one it had before it started to Columba and Ayebare mute. Columba, okay, it's just mute.
Teacher, I have a question. Teacher,
your audio.
0.99. I used a different method. Joules.
That's what?
The answer. I used a different method.
Okay. Let us finally see the loss in energy. Loss in energy. Is equal to the energy. Good. Is equal to the energy before. The loss in energy will be the energy before minus the energy after. How much have you lost? You check what you had before and then what you have right now. When you subtract, you get the loss. So before we had 2 joules. Now we have 3 joules. So our answer is 1 joule.
Excuse me, teacher. Teacher.
Yes.
Remember how I got 2 meters, then I subtracted 1.5, then I got 0.5 meters. Then that is what I used, and I got 1 joule. Is that also okay?
Okay, that is okay because it was loss in potential. That is okay. So for you got the potentials at each point.
Teacher.
First potential at A and the second potential at B. That is okay. Is any other person who got the 1 joule? Others failed.
Yes, I got 1 joule.
Whoever got 1 joule, up your hand. I might throw some sweets to you.
I also got 1 joule.
Can you buy for me breakfast?
Hey, you send me your number on WhatsApp. I send you money. But I can direct these KFC guys to your home.
No problem.
Teacher, you're serious?
Teacher, you give them the money, then they bring for us the eats.
Yes. Yeah, I'll send my mobile.
You family bucket.
Bucket is okay. 80,000.
I want a bucket.
Teacher, I have a question.
Okay, ask your question.
Teacher, I first got the velocity like 2 GH into square root. Yes. I got 5.47 meters per second.
Okay,
Afterwards, I found kinetic. Yes?
Okay, that is at point.
Afterwards, I found kinetic energy and got 2.99 joules.
Okay.
Then the loss in energy was 1.01.
Okay, approximately 1, eh?
Yes.
Okay, only that now you have to use this kind of information. And when the ball bounces, when they say the ball bounced, okay, what I didn't want to mention much, when the ball bounces to some level, it means its velocity is 0. At that point, when it bounces and goes back, it will reach some point and then stop and then come back. So at that point where it stops, the velocity is 0. Meaning that at that point, kinetic energy is also 0. That's why I have not used kinetic energy anywhere. I've only used potential and potential. When something bounces to some height, it reaches some height, rests, come back. So that's why we say potential energy, kinetic is 0 at that point. But now, as we close the class, the other number they can ask you, we have said in this topic that we are conserving energy. We don't lose our energy. Our energy just converts to other forms. Now my question is, in our working, we have seen loss in energy. After we are saying we don't lose energy. We don't lose, neither do we create. But again, we are getting an answer for loss in energy. So who can account for that 1 joule? Where has it gone? Because we don't lose it. Which other form has it changed it to, that 1 joule? Are you getting my heat? Aha. That 1 joule has been converted into sound and heat. When the ball bounces, hits the floor like this, there is some sound made. And after the sound has been made, then there is some heat. Yeah? So your 1 joule has been converted into heat and sound. That question, they will always ask you.
Guys, mute.
That's how they always ask that number. Account for the energy lost. Accounting means they're asking you to tell them how that energy has converted in other forms. So we shall say the 1 joule has converted into sound, heat, energy. That is what you always answer whenever they ask for this part. Let me call it part C. I have given it part C of our question. Account for the energy. Into sound and heat. Somebody is singing for us.
Sound energy.
And this part has marked the end of today's lesson.
Bye,
thank you, teacher.
Thank you,
teacher. Thank you, teacher, for teaching us.
Thank you, teacher, for
Highly
teaching
appreciate
us.
it.
Thank you, teacher.
God bless you.
Bye.
Bye.
So the next lesson is pressure.
Rihanna.
Oh,
this is pressure. Okay.
Our next lesson for the next physics lesson.
Teacher, some of us need support.
Bushra. You guys, can you come back here for roll call?
Some of us don't have data.
Sapphire, give us a break.
You guys line up for roll call.
And you also need fruit
for chasing our COVID.
Morocco.
Chasing away
Teacher,
COVID.
end the class.
You go for it alone. Go for your own code.
Shall we want break?
Teacher, my
Hey, you know what's
Teacher,
up?
you said you're sending me money.
You said break.
Number.
Teacher, we are going to inbox you our numbers. Send to our
Teacher,
mobile
I
money.
inboxed you my mobile money.
Hey.
I take it I'm
Condolences
going
of
to
mine.
Charity.
Inbox.
I will. My mobile money.
Okay.
Bye.
Okay,
Teacher, we are waiting for you to end the lesson.
Take care. I have ended the lesson. Next lesson is.
Thank you.
At what time?
The next lesson is not today. At what time? The one for today.
Charity.
We have physics and math.
Hey, the next lesson is. I'm saying the next lesson of today. The next lesson.
We are going for math.
Sorry to send your number.
Check your timetable.
Okay.
What?
Bye.
Bye.